Good morning, friends. Today we are going to discuss about the kinetic theory of gases. Already the most of the part of this chapter you learned in chemistry, like as the Boyle's law, Charles' law, also the Avogadro hypothesis, and what is the kinetic energy of the molecule of the gases that is directly proportional to the temperature of a gas. We are going to discuss in this chapter and what is the specific heat at constant pressure and constant volume, and what is the relation between them. Now in 11th standard we had to learn about the property of solid, properties of fluid, that means the liquid, and then the properties of the gases. In this chapter we are going to discuss about the properties or the kinetic theory of gases. So sometimes the question arises in our mind that what is the behavior of gases, or what is the kinetic theory of gases? What is the importance of study of kinetic theory of gases? Which type of the information we obtain from this type of the study about the gas? So there is in introduction we discuss about that, and after that we are discussing about the laws. That is, these laws are known as the laws of gas, Boyle's law, Charles' law, right? Okay. Now, first thing, in introduction, how behavior of the gases are explained. How we can explain the behavior of gases. For that purpose, we know that the gas is made up of the atoms or the molecules. That is not seen by our eye, right? Gas is made up of the atoms or molecules. Phenomena by which the properties of gases can be explained is known as the kinetic theory of gases. Again, the phenomena by which the properties of the gases can be explained, these properties are known as the kinetic theory of gases. Now, kinetic theory of gases is based on that gases are made up of the atoms of molecules, and these atoms of molecules are in motion with very high speed. Kinetic theory of gases is based on the gas is made up of the atoms or the molecules. These atoms or the molecules are in motion with very high speed. The speed of the, in short, the speed of the atoms or the molecules from the gas is very high. Now, the intermolecular forces, that is also known as the interatomic forces, in gases is very less compared to the solid and liquid. Already we know that what is the difference between the solid, liquid, and also the gas. All these three states of matter are made up of the atoms or the molecules. Solid is also made from the atoms or the molecules. Liquid or the fluid is also made up of the atoms or the molecules, the same as the gas. Now, what is the difference between the gas, liquid, and also the solid? In solid, the distance between the two molecules is very less. Generally, the atoms or the molecules are very close to each other in solid. While in liquid, the distance between the atoms or the molecules in liquid is quite more compared to the solid. While in gases, all the molecules are in random motion, and also the distance between the molecule or the atom is very large compared to the liquid and gases. Therefore, the force of attraction between the atoms or the molecule is very less compared to the liquid and solid, right? So in gases, the distance between the molecule or the atom is very large. Therefore, interatomic or the intermolecular forces is very less compared to the intermolecular forces in liquid or the solid. And due to that reason, we know that the solid is not compressible, less compressible compared to the liquid. Compared to the gas, liquid is also less compressible. Now, the gas state of any material is compressible because the distance between the atoms of the molecules is very large compared to the solid and liquid. So there is the behavior of the gases can be explained. Again, the gas is made up of the molecules or the atoms. Right? What is the kinetic theory of gases? The phenomena by which property of the gases can be explained. Due to which phenomena we can explain the property of gases, that is known as the kinetic theory of gases. Now, kinetic theory of gases is based on the gas is made up of the atoms or the molecules, and these atoms and molecules are in motion with very large speed. Okay. Now, one more thing about the gas. Interatomic or the intermolecular forces in gases is very, very small or the less compared to the interatomic or the intermolecular forces in case of liquid or solid. Clear this? So there is the basic information about the kinetic theory of gases. After that, again in introduction, what is the kinetic theory of gases and how it is useful? Which type of the information about the gas we can obtain by studying of the kinetic theory of gases. Now, the property by which the gases can be explained, or the phenomena by which the property of the gases can be explained, that is known as the kinetic theory of gases. Again, the property by which the gases can be explained is known as the kinetic theory of gases. Kinetic theory of gases explain which type of the property, pressure, temperature of gases in terms of the molecule. Kinetic theory of gases explain the pressure, temperature of gases in terms of the molecule. That means the pressure depends on the number of molecules and temperature also depends on the number of molecules. So we can explain the pressure and temperature in terms of the molecule by using the kinetic theory of gases. Now, the kinetic theory of gases consists of the gas law and Avogadro's hypothesis. In kinetic theory of gases, we learn about the gases law or the law of gases, like as the Boyle's law, Charles' law, Gay-Lussac law. Okay. And also, it consists of the Avogadro hypothesis. Avogadro hypothesis suggests the number of molecules in given quantity of a gas. We also discussed about the Avogadro's hypothesis. Okay. Now, kinetic theory of gases relate the measurable property of gas, like viscosity, pressure, temperature, internal energy, heat capacity, specific heat, conduction, diffusion with molecular parameter. From this, the estimation of the size and mass of the molecule can be done. So what is the use of the kinetic theory of gases? By studying the kinetic theory of gases, the different property like as viscosity, pressure, temperature, internal energy, heat capacity, specific heat, conduction and diffusion with the molecular parameter are studied. And from this, the estimation of the molecule size and also the mass can be done. We know that the atoms of the molecule can't seen by our eye. Therefore, we can't measure the size or the mass of this molecule by directly physical method. Clear? For that purpose, this type of the study is carried out in kinetic theory of gases. Again, what is the kinetic theory of gases and how it is useful? The property by which the gases can be explained is known as kinetic theory of gases. The property by which the gases can explain is known as kinetic theory of gases. Kinetic theory of gases explain the pressure, temperature of gases in terms of the molecule. Again, the kinetic theory of gases explains the pressure, temperature of gases in terms of molecule. Okay. Now, it consists of the gas laws and Avogadro's hypothesis. That means in kinetic theory of gases, the gas laws and Avogadro's hypothesis are also included. Now, kinetic theory of gases relates the measurable properties like as the viscosity, pressure, temperature, internal energy, heat capacity, specific heat, conduction, diffusion with molecular parameter. From this estimation of molecular size or mass can be done. So by studying this property like as the viscosity, pressure, internal energy, temperature, specific heat capacity, conduction and diffusion with molecular parameter, we can estimate the size and mass of the molecule of the gas. So that is the application of the kinetic theory of gases. Clear this? So that is our basic introduction about the kinetic theory of gases. Now next is the basic law that is known as the Avogadro's hypothesis for gases. So question arises in our mind that for each and every gas, the number of molecules are same, if its mass, its volume are same, pressure same and temperature are same. So for all the gases, the number of molecules are same. These gases are at equal pressure, temperature and also the volume. So this type of the explanation can be done by the Avogadro. Now the question is that explain Avogadro's hypothesis by relating pressure, temperature and volume of gas. Explain Avogadro's hypothesis by relating the pressure, volume and temperature of a gas. Now we know that the equation of the relating the pressure, temperature and volume is PV is equal to KT. PV, product of the PV is already constant at given temperature. That means that it depends on the temperature. PV is equal to KT or the PV proportional to the temperature T. Therefore, PV is equal to KT. Here T is the temperature in Kelvin. K is equal to constant for a gas. Constant for a gas. Now, this K depends on the volume of a gas. That means that it depends on the number of molecules in a gas. Here this K is proportional to the numbers of atoms in a gas. Therefore, this capital K directly proportional to the number of atoms. To remove this proportionality sign, we introduce the constant that is known as the Boltzmann constant Kb. Here Kb is known as the Boltzmann constant. This type of the small k or the Kb, that is known as the Boltzmann constant. So here this K, capital K is proportional to the number of atoms in a gas, therefore K proportional to the capital N. To remove this proportionality sign, we introduce the constant that is the Boltzmann constant. Therefore capital K is equal to small k into N and small k that is also denoted by Kb. K suffix B, that is known as the Boltzmann's constant. A SI unit of Kb or the Boltzmann constant is Joule per Kelvin and its dimensional formula is M1 L2 T minus 2 K minus 1. K is for Kelvin, T for time, L for length and M is gram or the kg mass. Again M1 L2 T minus 2 upon temperature, that is the dimensional formula of Joule, upon temperature. Temperature is measured in Kelvin. Therefore, dimensional formula of Boltzmann constant is m1 L2 T minus 2 K minus 1. Yeah. Okay. Now our equation 1 is PV is equal to KT. Equation 2 is K is equal to small k into n or small kb into t into n. Comparing these two equations or substitute the equation 2 in 1, therefore PV is equal to KB and T. KB and T. Right? So from this equation, PV upon NT is equal to KB. KB is the Boltzmann constant, that is constant. Right? Okay. So we can write like this: P1 V1 upon N1 T1 is equal to P2 V2 upon N2 T2, because the PV upon NT is constant. So there is an initial condition, there is in final condition. The ratio of PV upon NT is remain constant. Thus, if for all cases PVT is same, then the N also same. Number of molecule also same. If for all gases pressure, volume, temperature are same, then number of molecules in these gases are also same, which represents Avogadro's hypothesis. That represents the Avogadro's hypothesis. Now, what is the statement of Avogadro's hypothesis? Equal volume of all gases at equal temperature and pressure. Equal volume of all gases at equal temperature and pressure have equal number of molecules. That means for all the gases, if the volumes are same and this volume are at same or the equal temperature and pressure, the number of molecules in all gases are also equal. Equal volume of gases at equal temperature and pressure, the number of molecules are same or the equal. So this statement is known as the Avogadro's hypothesis. Avogadro's hypothesis. That is the basic law about the gas, or that is the basic study of, or the study of the kinetic theory started from Avogadro's hypothesis. We can judge about the number of molecules in given gas. Again, what is the behavior of gas? Or explain the Avogadro's hypothesis by relating the pressure, temperature, and volume of a gas. For that purpose, the equation of, or the equation relating the pressure, volume, and temperature. Pressure, volume, and temperature is PV is directly proportional to T. Therefore, PV is equal to KT. Temperature T is in Kelvin, and K is the constant for gas. We start from this to derive the Avogadro's hypothesis, or to explain the Avogadro's hypothesis. The equation of, or the equation relating the pressure, temperature, and volume is PV proportional to T. Or in other words, PV is equal to KT, K is the constant, and T is temperature in Kelvin. Now this capital K is proportional to the number of molecules in gas. Number of molecules in a gas. Therefore, K is directly proportional to the capital N. N is the number of molecules. To remove this proportionality sign, we introduce the constant, that is the small k or kb. Therefore, capital K is equal to small k into n or kb into n. Kb into n. That is our equation number 2. Yeah, small k or kb is known as the Boltzmann constant. That is known as Boltzmann's constant. And its SI unit is Joule per Kelvin. Its dimensional formula is, Joule has the dimensional formula is m1 L2 T minus 2 upon Kelvin, that means the temperature is K1. So K1 taken in numerator, therefore M1 L2 T minus 2 K minus 1 be the dimensional formula of Boltzmann's constant. Substitute equation 2 in equation 1, therefore PV is equal to KBN into D. KBN into D. So that is our equation. PV is equal to KBNT. Therefore, PV upon NT is equal to KB, but the KB is the Boltzmann constant, so there is constant. Again, from this equation, PV is equal to KB into NT, therefore PV upon NT is equal to KB is equal to constant. Therefore, P1 V1 upon N1 T1 is equal to P2 V2 upon N2 T2. Thus, if for all cases PVT are same, PVT are same, the N also same, number of molecules also same. If the gases have the pressure, volume and temperature are same, so these gases also have the same number of molecules, which represent the Avogadro's hypothesis. Therefore, Avogadro's law is that, or the statement of the Avogadro's hypothesis is that equal volume for all gases at equal temperature and pressure have equal number of molecules. Again, the Avogadro's law is that equal volume of all gases at equal temperature and pressure have equal number of molecules. Again, what is the Avogadro's law? Equal volume of all gases at equal temperature and pressure have equal number of molecules. So this is the Avogadro's hypothesis. Clear it? Okay.